All right. Review of section 4. Find the number of positives and negative solutions of this polynomial. List all possible solutions. Find me the y-intercept and the x-intercepts. Number 1, to find the number of positives and negative solutions, what method do we use? Very good. To find the number of positive and negative solutions, we use Descartes' rule of signs. So how does that work? So the number of positive answers. Count the number of sign changes. So positive to negative, that's 1. Negative, negative, nope. Negative to positive, that's another one. Positive to negative, that's 1. Negative to positive, that's 1. So count those. There are 4 or 2 or 0. Why is it 4, 2, or 0? That's the sign changes, right? Because if we have imaginary or radical answers, square, they always have to come in conjugate pairs. So that's why, in case if there's no imaginary or radicals, or if there's one set, or if the 2 sets, that's why we always subtract by 2. Okay. The number of negative solutions. We have to first, anything that has an odd exponent, change the sign in front of it. If it's even, don't worry about it. Leave it alone. So I only change the signs in front of the odd exponents. The reason being, because what I have to do is I have to change all the x's to negative x. And the only place that is affected is on the odd exponents. Even exponents cancel out the negatives. So that's negative to negative, nope. Negative to positive, that's 1. Positive, positive, nope. Positive, positive, nope. So we only have 1 negative. So we could either have 4 positive answers and 1 negative, or we have 2 positive answers, 1 negative, and 2 imaginary, or we can have 4 imaginary, no positives, and 1 negative. But we have to have 1 negative. How does that help us? Because once we find the negative answer, we don't have to look at any more negative answers. We just look at the positive answers. So that's the first part. Find the number of positive and negative solutions. List all possible solutions. How do you do that? To find the list of all possible solutions, use the rational zero theorem. Remember what the rational zero theorem, what it said? The rational zero theorem is this. It's P over Q, where P is the last digit and Q is the leading coefficient. What we have to do is find all the permutations of what makes up 15, everything that makes up 2. So we have 1 times 15 or 3 times 5. What makes up 2 is 1 times 2. Now we take all of these over 1. So it's 1 over 1, 3 over 1, 5 over 1, 15 over 1. Now over 2. We have 1 over 2, 3 over 2, 5 over 2, 15 over 2. All of these, of course, are plus and minus. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 1/2, 3 halves, 5 halves, and 15 halves. So we take all possible combinations of these. We narrowed it down from infinity to these. And we know only 5 of them at most will work. And 1 of them is negative. So we have 8 sets, and they're positive and negative, so there's 16 possibilities. How do you go through them? What do you have to do? Yeah, how? Using what method? The synthetic. So we'll try with 1 and -1 first. Remember, inside here only goes the coefficients of your function. 2, -1, -4, 2, -30, 15. 2, -1, -4, 2, -30, 15. So what we do now is bring down the first term, and we begin our process of synthetic division. We stalled as long as we could. Actually, this is our first question of the day. We're reviewing section 4 right now. This of using Descartes' rule of signs and the rational zero theorem. So 1 times 2 is 2. 2 minus 1 is 1. 1 times 1 is 1. 1 minus 4 is -3. 1 times -3 is -3. -3 plus 2 is -1. -1, so it makes it -31. -31 is -16. So 1 is not an answer. So we do the same thing with the -1. -1 times 2 is -2. -1 plus -2 is -3. -1 times -3 is 3. -4 plus 3 is -1. -1 is +1. 2 plus 1 is 3. -1 times 3 is -3. Let's make it -33. Negative is positive. 33 is 48. So -1's not right. Because what are we looking for? What are we looking for here? 0. Has to be 0. If it's not 0, it's not a factor. All right, so 1 doesn't work. Do the same thing with plus or minus 3, plus or minus 5, plus or minus 15. We keep on going. There you go. I mean, here's the question. Here's the number we're using. Here's the equation. And these are the 4 questions we're asked. 4 questions. Okay. So let's try it with 3 and -3. So it's 2, -1, -4, 2, -30, 15. 2, -1, -4, 2, -30, 15. Bring down the first one. Is everybody okay with synthetic division? So this is a whole process of multiplication, addition, multiplication, addition. 3 times 2 is 6. 6 minus 1 is 5. 3 times 5 is 15. 15 minus 4 is 11. 3 times 11 is 33. 33 plus 2 is 35. 3 times 35 is 105. Minus 30 is 75. Yeah, it's not going to work. That's going to be way too big. So 3 is not it. It's just going to become bigger. You're going to add those. Now, bring down the first one. -3 times 2 is -6. -6 plus -1 is -7. Negative is positive. 3 times 7 is 21. 21 minus 4 is 17. 3 times -17 is -51. Plus 2 is -49. 3 times 49 is 147. Minus 30 is 117. Nope, -3 doesn't work. So positive -3 doesn't work. So now we got to do 5 and -5. So we have 5 and -5. 2, -1, -4, 2, -30, 15. 2, -1, -4, 2, -30, 15. -1, -4, +2, -3. Bring down the first term. 5 times 2 is 10. 10 minus 1 is 9. 5 times 9 is 45. Minus 4 is 41. 441 times 5 is 205. Plus 2 is 207. It's going the wrong direction. So that's not going to work. -5 times 2 is -10. Plus -1 is -11. Negative is a positive. 5 times 11 is 55. Minus 4 is 51. -255. Plus 2 is -253. Nope, going in the wrong direction. So that's not going to work. Then we got to do 15. Okay, so we have 2, -1, -4, 2. So everybody got my message on Monday, right? You got my message on Monday? Okay. Yeah, so you must have gotten the wrong code somewhere. I don't know how you got the Saturday code. $15 times 2 is 30. 30 minus 1 is 29. Holy smoke, that's going to grow. That's going to just destroy it. 15 times 29 is 330, 325. Minus 4, no, that's not going to work. $15 times 31, 45. 60 or 600. No, that's not going to work either. So that means it's got to be fractions. -1/2. -1/2. Instead of bobbleheading, I want you to try it yourself. Try to get it yourself because that's the only way you're going to understand it. -1/2 times 2 is 1. 1 minus 1 is 0. 0 is -4. 1/2 times -4 is -2. That's 0. -30. 1/2 times -30 is -15. Yes. There's our first solution. It's a +1/2. Again, don't bobblehead. If you don't understand the process, tell me, I can walk you through it, but bobbleheading is not going to help you. So now we only have to use this polynomial. But just for giggles, let's go ahead and have that one written down. -1/2 times 2 is -1. -1 is -2. Negative and negative, positive. 1/2 times 2 is 1. -3. 3 halves. 3 halves plus 4 halves is 7 halves. -7/4 is 120/4. So -127/4 over 8. It's 127/8. 8 times 15. 8 times 5 is 40. That's 120, so it's, oh, that's going to be big. It's 247/8. Nope. So we know that x equals 1/2 is one solution. So that means we have to have at least one more positive and one negative. So let's go on from there. But now we just have to use the smaller one. 2, 0, -4, 0, -30. 2, 0, -4, 0. That's the 5. That was the 1/2. So it's now 3/2. -3/2. Three over 2 times 2 is 3. 0 plus 3 is 3. 3/2 times 3 is 9/2. 4 is 8/2. Plus -8/2, so it's 1/2. 3/2 times 1/2 is 3/4. And then 9/8. 3 halves times 3/4. And that's not going to cancel. Two times -3 halves. 2's cancel, so it's -3. Negative is a positive. 3 times 3 is 9/2. 8/2. Positive. That's 3. 9/2. -3. Negative is a positive. And then it's going to be a -3/4 plus 0 is -3/4. Positive 9/8. No. All right, so what do we do first? Bring down the 2. 5/2 times 2 is 5. 0 plus 5 is 5. 5 over 2 times 5 is 25 over 2. And that's negative 8 over 2. So it's 17 over 2. $85 over 4. Nope. This is 8 over 2. Subtract 8 from 25 is 17 over 2. Negative 85 over 4. And we're down to the last one. Go ahead and work those out. So 2, 0, negative 4, 0, negative 30. So do either of these work? Two is 15. No, this one's grow much bigger. Same with that. Okay, so let's see what we have. We know for sure we have that as a solution. And this is the remainder polynomial. Let's see what that looks like. So we have x equals 1/2. And then we have 2, 0, negative 4, 0, negative 30. This is a constant x squared, x cubed, x. So this is 2x to the 4th minus 4x squared minus 30. That's what's left on the equation. And this one, 2x equals 1, 2x minus 1 equals 0. So we have our first solution here. Does this look familiar? Well, do they have anything in common? They have a 2 in common. So we factor out a 2. Remember, whatever you solve these, you always solve for the middle. So it's x squared, x squared. Opposite signs, the bigger number is that. So what times what is 15? When you subtract them, you get 2. 5 and 3. Because this is what's called quadratic in form. That's what we did earlier in the chapter. No, x squared. No, we're solving for x. We're not distributing. So now we know our solutions. This one is going to be x equals 1/2. Let's solve both of those. We have x squared plus 3 equals 0. X squared minus 5 equals 0. Subtract 3 from both sides. Square root. So x is equal to plus or minus, since there's a negative in there, it's an I radical 3. So what this means, x I radical 3 is one factor, x minus I radical 3 is another factor. So we have two imaginaries. How about this one? X squared minus 5 equals 0. Add 5 to both sides. X squared equals 5. Square root both sides. X equals plus or minus square root of 5. So the solutions here those are the factors. So these are our 5 factors to our polynomial. Which sucks. It's a lot of work. I was hoping, I just picked one from the book. I was hoping it was going to have nice answers. Oh, I was wrong. But you at least see what happens if none of the answers work. Because remember, as long as we knew we had to have one. We knew we had to have one negative answer. We can have either 4, 2, or 0 positive answers. And then imaginaries or radicals, we can have 0, 2, or 4. Because they have to come in conjugate pairs. And that's exactly what happened. Okay, let's get away from that. You want to do some more or want to move on? Section 5. Okay, let's try another one. We're doing the same things. Excuse me. We're going to find the, we never found the the y-intercept. The y-intercept is the constant, it's 15. Yeah, so this one, the y-intercept is -4. It's 0, -4. That's the y-intercept. The x-intercepts, we have to solve for it. Number of positive, number of negative solutions, and all possible solutions. Oh, crap. That means everything I just talked about was not recorded. I started, oops. All right, so here's our equation with number of possible positives is the sign changes. We have 3 of them or 1 of them. For the possible negative solutions, if it has a negative odd exponent, just change the sign in front of it. So that positive comes, that negative comes positive, that positive comes negative. Now count the sign changes. Positive, positive, there's 1. So we're going to have 1 negative solution, either 3 or 1 positive solutions. The possible outcomes, looking at the P of, so it's the last digit, the 4 over the 3, 4 over 3. So look at the factors. 1 times 4, 2 times 2 makes up 4. 1 times 3. So look at all the possible combinations of 1 over 1, 2 over 1, 4 over 1, 1 over 3, 2 over 3, 4 over 3, and positive or negative. So 1 over 1 is 1, 2 over 1 is 2, 4 over 1. So those are our possibilities. So we do synthetic division. Start with 1 and negative 1. That's negative 2. Here's our first 0. Note, very important. Since our equation is missing an x squared, in this, when we do synthetic, we have to have a 0 holding that column open. So that's why it's x to the 4th, x to the 3rd, x squared, x and constant. So we found our first 0 at negative 1. So that takes care of our negative answer. So we don't have to try any more negatives. So, but now all we have to do is solve for this equation. So positive 2, if we did that, nope, we got 8. And I try to, of course, it's not going to work, it's just getting bigger and bigger and bigger. Positive 4 gives us 20. 1 over 3 gives us a weird number. At 2/3, we get a 0. So we know that 2/3 is another solution, which now if we're as a factored, multiply both sides by a 3, subtract 2. So this is a factor. And all we have to do now is look at this equation. That's what we did here. Since it's quadratic, constant x squared. They all have a 3 in common. Take it out. This is what we're dealing with. It can't factor because what times what is 2 when you add them to get 4? It doesn't exist. So we have to use quadratic formula. A is 1, B is negative 4, C is 2. And plug them in there and work it out. So negative 4 plus or minus square root of negative 4 squared minus 4, 1 times 2 over 2. This becomes a positive. Negative 4 squared is 16. 4 times 1 is 4 times 2 is 8. 16 minus 8 is 8. So it's 4 plus or minus square root of 8 over 2. 8 can break down to 2 times 2 times 2. Since you're in a radical and you have 2 of a kind, that can come out in front. So that's those 2 comes out in front. We only have a 2 left inside there, that one. 4 and 2 have a 2 in common, so we can factor that out. That cancels with the bottom, and there are our last 2 answers. So these are our 4 solutions. And the factors are x plus 1. The bottom goes in front, so it's 3x minus 2. X minus 2 plus minus square root of 2. X minus 2 minus square root of 2. These are your 4 factors. Those are your 4 intercepts. Which brings us to this next question. That's where we are now. I gotta fix that from now on. So we have our sign changes. Well, let me make sure. So our positive ones, we have 1, 2, 3, or 1 positives. It could be So that's going to change to positive. It's a negative. So we have positive to positive, positive, positive. So we have one. So for the negatives, we have positive to positive, positive to positive, positive to negative, and negative. So we only have one sign change. We only have one sign change for negatives. We found it. So we're done with the negatives. Because remember, whenever you're looking for the sign change for negatives, only change the sign in front of the odd exponent. So we're looking at 3x to the fourth. That's minus, change it to plus. Leave that one alone. Change this one, since that's a one exponent. That's constant. So we have positive, positive, one sign change. So we found the only negative answer. We have 3 more to go. Let's hope they're positives. So we're done with the negatives. So we did 1 and -1. We found that -1 works. Two times 3 is 6. 6 minus 7 is -1. 2 times -1 is -2. 8 minus 2 is 6. 12. 6 times 2 is 12. Is 10. That's not going to work. So let's try 1/3. Bring down the first term. 1/3 times 3 is 1. -7 plus 1 is -6. -6 divided by 3 is -2. 8 minus 2 is 6. 1/3 times 6. 6 divided by 3 is 2. So there's our next solution, 1/3. So now we only have to look at 3x squared minus 6x plus 6 equals 0. Because when you find the 0, this one's the constant x squared. They all have a what in common? 3. So I can factor out a 3. I have x squared minus 2x plus 2. As you can see, it's not going to factor, so we have to use what method? The quadratic formula. If you ever can't factor it, don't waste your time, just go jump straight to that. A, B, C. What is A? Is 1. Very good. B, -2. And C, 2. Excellent. So we have -2 plus or minus -2 squared minus 4 times 1 times 2 over 2 times 1. Plug in A, B, and C inside there, and let's go. Negative and negative becomes a positive. -2 squared is 4. 4 times 1 times 2 is 8, so it's -8 over 2. Four minus 8 is -4. There's a negative inside there, so that's an I. Square root of 4 is 2, so it's 2i. The top, we can factor out a 2, leaving us 1 plus or minus I over 2. The 2's cancel. Those are the last two solutions. Okay, so I was wrong. I thought they're all going to be nice answers. But you see what happens if it doesn't work out, you'll have imaginary answers. So don't think your method's wrong. Keep on going. There's no other alternatives. So the factors of this equation are, what this is asking us is the polynomial was 3x to the 4th minus 4x cubed plus x squared plus 6x minus 2. The factors are x equals -1. So it becomes x plus 1. X equals 1/3, multiply by 3 and subtract 1. So it's 3x minus 1. And then these two. X minus 1 plus I, x minus 1 minus I. Those are your 4 factors. Any questions so far? So is it getting better at least? You have to know how to do the synthetic division. If you don't know how to do synthetic division, that's the most important thing to learn. If anything today, that's the most important thing to learn how to do. Want to do another one or move on? I don't mind. I mean, trust me, I don't mind doing another one. Who wants to do another one? Okay. We have a yes. Trust me, I don't mind doing it at all. F of x cubed plus 5x squared minus 2x minus 10. Same thing. Find me the positives, negatives, and the rational zeros. Okay. So the number of positive answers. Positive, 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 negative, that's 1. Negative. So we have 1. Change the signs of only the numbers that have an odd exponent. This is a cube, so that's going to change from positive to negative. That's a 1, so it changes from negative to positive. 1, 2. So we have that. Ten over 1. We're done with this one. So 10 over 1, which is 1, 2, 5, and 10. So my possible zeros are at plus or minus 1, plus or minus 2, and 10. That's it. So that makes it easy for us. There's no fractions. How many answers are we supposed to have? We're supposed to have 3. So we'll have 1 positive, possibly 2 negatives. If not 2 negatives, then we'll have 2 either imaginary or radicals. So let's try 1 and -1. So we just put the coefficients down. 1, 5, -2, -10. 1, 5, -2, -10. Bring on the first one. Now multiply. 1 times 1, answers there. Now add up and down. 5 plus 1 is 6. 1 times 6. 6 minus 2 is 4. 1 times 4 is 4. 4 minus 10 is -6. That doesn't work. Another one. -1 times 1 is -1. 5 minus 1 is 4. -1 times 4 is -4. -4 plus -2 is -6. Negative is a positive. 1 times 6 is 6. 6 minus 10 is -4. So that doesn't work. So all the ones are gone. Let's try 2 and -2. Repeat the process. 1 times 2 is 2. 5 plus 2 is 7. 2 times 7 is 14. 14 minus 2 is 12. 2 times 12 is 24. 24 minus 10 is 14. Nope. Let's try -2. -2 times 1 is -2. 5 minus 2 is 3. -2 times 3 is -6. -6 plus -2 is -8. 2 times 8 is 16. 16 minus 10 is 6. Nope. Uh-oh, we're running out of answers. -5. 1, 5, -2, -10. Five times 1 is 5. 5 plus 5 is 10. 5 times 10 is 50. Minus 2 is 48. It's not going to get close. 240. Minus 10 is 230. Nope. -5 times 1 is -5. 5 minus 5 is 0. -5 times 0 is 0. -2 plus 0 is -2. -5 times -2 is +10. Yes, there's our first answer. So x equals -5. And these are our last two. So remember, this is constant x and x squared. So we have x squared minus 2 equals 0. So add 2 to both sides. X squared equals 2. Square root x equals plus or minus square root of 2. So these are the x-intercepts. What are the factors? So for example, x equals -5. Make it equal 0. Add 5 to both sides. So x plus 5 equals 0. So x plus 5 is a factor. X plus radical 2 is a factor. X minus radical 2 is a factor. So those are the three factors. Much better? The hardest and longest part is the synthetic division, going through each of the possibilities. And it gets even worse when you get down to the fractions. And so that's when it gets worse. But it's doable. So now there's not one polynomial out there that you really can't solve. You can find the x-intercepts, you can find because remember, these are the x-intercepts. What you're solving here are the x-intercepts. You know the y-intercept, that's the constant. You know the shape of it, it's a cubic equation, and it's positive, so it'll look like this with three intercepts. What do you think? You want to do the next chapter? It's rationals. We only have two, I mean, there's two sections. We only have two sections. Section 5 deals with rationals.